You know the Star Trek transporter, right? Well, what if converting the human body into energy and back wasn't just science fiction? I mean, that represents the ultimate mastery of converting matter into energy and back again. For a long time, we kind of viewed matter and energy as completely separate domains, but understanding their intimate, inseparable link is literally the true foundation of general chemistry. Just think about a nuclear reactor for a second. Matter is quite literally converted into energy there. When we start looking at the universe this way, we quickly realize that understanding the stuff around us is the absolute key to understanding reality itself. Welcome to this explainer. Today, we're diving headfirst into the everyday magic of general chemistry. And hey, let's get one thing straight right off the bat. Chemistry is far from being confined to some isolated, sterile laboratory. No way. It is the fundamental science of our very existence. We're talking about a continuous, massive cycle of transformations happening all around us every single second of the day. By the end of our time together, I promise you'll be looking at the physical world in an entirely new, deeply interconnected way. All right, so here is our roadmap for today's explainer. First, we'll cover the fabric of the universe. Second, thinking like a scientist. Third, the atomic perspective. And finally, number 4, chemistry in your home. Let's get right into it. Section 1, the fabric of the universe, matter and energy. So what exactly is chemistry? Well, fundamentally, it's the study of the composition, structure, properties, and the transformational changes of matter. Now, defining matter as simply anything with mass and volume is totally standard, right? But the really absolutely crucial focus here is that word transformations. You see, chemistry isn't merely about what things are sitting still. It's all about what they become. It's literally the study of how the basic fabric of reality undergoes this continuous, nonstop alteration. Now, you might be wondering, what's the real difference between chemistry and its close cousin, physics? Well, it essentially boils down to motion versus transformation. Where physics uses fundamental mathematical equations to describe forces in motion, like say a ball rolling down a hill, chemistry steps in and asks, okay, but how might that ball oxidize or even combust along the way? They're both physical sciences for sure, but they apply a distinctly different lens to the exact same reality. Section 2. Thinking like a scientist, the framework. Okay, so to really truly grasp these mind-blowing transformations of matter, we have to rely on the scientific method. Chemistry is a science that is grounded entirely, and I mean entirely, in observation and experimentation. Here's how it flows. A chemist makes an observation, then forms a tentative hypothesis to act as kind of a guide, and then they rigorously test it. But here's the kicker. The absolute cornerstone of this whole framework is reproducibility. Basically, if an experiment cannot be independently verified by other folks in the scientific community, well, it holds no weight whatsoever. It is an incredibly rigorous framework for parsing out objective truth from mere assumption. And when those experiments are repeatedly verified over and over and over again, they eventually solidify into what we call the laws of science. These laws summarize just absolutely vast numbers of experimental observations to confidently describe or even predict specific facets of the natural world. You can think of them as effectively the rules of the game for our entire universe, all discovered through that exact framework we just outlined. Section 3, the atomic perspective, the microscopic world. Think about the stark contrast between macroscopic bulk systems, like, watching colored liquids interacting in a beaker, and the microscopic atomic standpoint. In chemistry, really understanding the visible behavior of the macroscopic world actually requires mastering a totally invisible domain, a domain where particles are exponentially smaller than even human cells. It's like a giant puzzle where you're constantly interpreting the large scale through the lens of the infinitely small. This brings us to Dalton's atomic theory, which established a profoundly foundational truth. Atoms of different elements combine to form compounds, but, and this is a really big but, they are never actually created or destroyed in a chemical reaction. They are only rearranged. Now, sure, our understanding has definitely evolved since then to include all sorts of tiny subatomic particles. But actually, scratch that, the core premise itself still holds up perfectly. It remains this incredibly elegant and powerful rule of atomic behavior. When you look at how molecular bonds work, you really see this rearrangement playing out in practice. A chemical reaction is, at the end of the day, simply the separation, combination, or reconfiguration of these structures. The starting atoms are perfectly identical to the ending atoms. They've merely found new structural partners. It's exactly like disassembling a Lego castle to build a spaceship using the exact same blocks. The pieces don't change, just the whole shebang they create together. Section 4.
Chemistry in your home, consumer chemistry. Okay, let's get into some everyday stuff. A chemical is simply a substance that maintains the exact same composition and properties wherever it happens to be found. Things like water, sodium chloride, which is just table salt, and the very oxygen we breathe are ubiquitous chemicals. They are definitely not just bizarre laboratory anomalies. It's a really necessary intellectual reminder that chemical structures literally define the absolute entirety of our environment.
And consumer chemistry is a massive, massive branch of manufacturing that leverages this exact reality. Whether we're talking about the formulation of cleaning agents, your morning cosmetics, or pharmaceuticals, initiating chemical reactions is just an everyday occurrence. I mean, from adding bleach to your laundry to break down those complex stain molecules, right down to dropping a fizzing antacid tablet into a glass of water after a big meal, chemistry is deeply, intimately integrated into our daily survival and our comfort. Take saponification, for instance. Now, I know that sounds like a big, intimidating word, but it's just the reaction between fatty acids and glycerol to produce soap. It's a perfect everyday example. The real key to this process lies in understanding the difference between plant-based oils, which are liquid at room temp, and animal-derived fats, which are solid. Chemists actually use these specific molecular properties to design the soaps and shampoos sitting in your bathroom right now, making sure they perfectly bind to the oils on your skin so you can effortlessly wash away dirt. It's brilliant. There's a great quote from the source material that says, "All the things you see around you are composed of one or more chemicals." I love that because it perfectly challenges chemophobia, that completely irrational fear of the word chemical. Because honestly, whether a process is taking place in a high-tech pharmaceutical lab, an industrial manufacturing plant, or naturally churning away right inside your own digestive system, it is all fundamentally chemistry. We really shouldn't fear chemicals. We should be actively seeking to understand them because they are the literal building blocks of our entire reality.
So, all of this leaves us with one final thought. Since you now know that absolutely everything around you is made up of chemicals, and that every single action involves rearranging tiny, completely invisible atoms, well, what everyday chemical reaction are you going to initiate next? Are you going to strike a match? Maybe bake a cake? Or are you simply going to take a deep breath,